Did that work for the video? Oh, that's perfect. Excellent. Welcome, everyone. We're going to talk about mocking in front-end and back-end TypeScript tests. And mocking is really fun. TypeScript adds another layer of it to be able to do syntax checking. With mocking, we're going to replace real stuff with fake stuff so that we have more control over it. Here's the part where I tell you I am definitely going to post the slides on my site tonight. I've chased similar speakers trying to get slides, which is why you can head to robrich.org. Let's do that now. And while I'm on robrich.org, I can click on presentations and scroll up to the top. Here is mocking in front-end and back-end TypeScript tests, the slides, and the code that's up on GitHub is online right now. Achievement unlocked. Woohoo! While we're here on robrich.org, let's click on About Me and learn about some of the things that I've done recently. I am a Jetpack developer advocate, a Microsoft MVP, MCT, Docker captain, and a friend of Redgate. AZ Give Camp is really fun. AZ Give Camp brings volunteer developers together with charities to build free software. We start Friday after work. Sunday afternoon, we deliver the completed software to charities. Sleep is optional, caffeine provided. If you're in Phoenix, come join us for the next AZ Give Camp. Or if you'd like a Give Camp here in Porto or wherever you traveled from, hit me up on email or Twitter, or see me here at the conference, and let's get a Give Camp in your neighborhood too. Some of the other things that I've done, Pro Microservices in .NET 6. I got to work with Sean and Matt on that. That's a really fun book. Just came out. You can grab it on Amazon. And one of the things I'm particularly proud of, I replied to a .NET Rocks podcast episode. They read my comment on the air, and they sent me a mug. Woohoo! So there's my coveted .NET Rocks mug. And if you'd like it, no, I'm just kidding. So let's talk about mocking. So we have an application that we're going to play with today. And I love this application because it focuses on a simple concept, but there's enough complexity in here that we can do some interesting things. So we see that, once I win, I can do that. And once I've won, I can't click on any of these other squares. Also, once I've set the square, I can't change the square. So we have some interesting business rules happening here. We also have a leaderboard. It looks like X is winning. X has gotten 20. And so we're going to play with this app throughout the talk to be able to play with how do we mock various dependencies to be able to test these. Now, what's interesting is this leaderboard is actually stored in the server. My server here is a Docker Compose file that starts a Redis server. You can grab this code at this link, and here's that Docker Compose file that fires up Redis. So when I'm testing a web server, I probably want to test lots of different pieces. I want to do things like test various functions. I just want to fire various input at this function, get various output out of this function. I want to be able to test the function. I may have web components where I want to be able to test either the rendering capabilities of this component or the user interactions with this component. I might want to test from here down. And here might be an interesting place. Maybe I start at the API and test from the API down. Or maybe I start at my web tier and I test all the way through all the user interactions. I might want to test a particular service. So maybe it's a GraphQL service or a REST endpoint. The beautiful thing here is that we don't need a browser to do this. We can just fire requests at it and see how that works. And I might want to test end-to-end. I might want to take user experiences to be able to drive through interesting things. I might also want to validate that my unit tests run in a particular browser. Now with HTML5, that's less of a concern. Browsers have kind of become more standard. But I may still want to validate that it works in Safari. So with each of these types of tests, I might have different tools that I would use to accomplish this. Now, the cool part is, as you grab these slides from robrich.org, you can click on each of these blue links to learn more about those packages. If I want to test a particular function, I might use Mocha with Chai or Jest. If I want to be able to validate that these unit tests run in a particular browser, I can start them with Karma. Now, the beautiful thing about Karma is Karma launches my unit tests in a browser. Now, this isn't users clicking buttons, this is unit tests, but I get to fire those requests in various browsers. And so that's really cool. I can do component unit tests. Now, TestUtils has a version for various SPA frameworks. So if I'm using Angular, React, or Vue, I use TestUtils to make that happen. If I'm doing API tests, I don't need a browser. I can just take supertest or request, and I can just fire requests at that service. And then end-to-end tests, I might use something like Selenium or Cypress. Now, in the app, we'll see examples of all of these tests, but I have that two sides of it. I have the API and the app, the thick client in the browser, and then the service that allows me to persist that leaderboard across different places. Now, the interesting thing with each of these types of things is I'm validating particular behaviors. And so then the magic question is, well, which tool do I need in which case? Now, I'm probably going to use lots of these tools to be able to accomplish different types of tests. And here we're going to see front-end tests and back-end tests using various tools. So then let's add mocking. Now, the cool thing is with TypeScript, I have some really elegant ways to be able to validate my content. So TypeScript adds design time hints to easily catch bugs and syntax errors. The cool part is TypeScript is just a design time experience. So at the end of the day, I'm going to take TypeScript away and I'm going to compile it into JavaScript. And what runs in the browser is just JavaScript. But the TypeScript allows me to get really cool hints. Now that does sometimes lead to this battle of wills where it's like, how do I make this type system work? And so we'll bump into some of that today too. As we add mocking to this, mocking allows us to test the thing. The core principle of mocking is, how do I test this thing without also testing that thing? How do I put in a fake that thing so that I can validate this thing in various components? So let's take some code here that does some interesting stuff. Now, in this code, we're going to pass in a date, and we're going to use that date to do some data access. Now, the interesting thing here about this data access is that the results of this data access component are not really relevant to this test. I want to be able to validate that, maybe this map and this reduce work correctly, but I don't need a data store. So how do I validate this code without a data store? Let's pivot to a similar concern where I have this function. Now, in this case, we don't have a whole lot of data store dependencies. We're just passing in this object. Now, this object probably has lots of properties. All of those properties are interesting, but the properties that I care about are just these two. I care about the end date and the start date. Now, TypeScript says that I need to build one of these big type things. So that means that somewhere in my test, I'm going to have to enumerate all of these stupid properties I don't care about. And if ever I add a new property to, this huge type, then I probably need to update my test. I don't care about any of that. I just care about the end date and the start date and having a deterministic result. So that's the problem. How do we pass in dependencies where we only care about a subset of that content? And how do we abstract away the imports that so that we can focus in on the units that we really want to test? So in TypeScript, most things are singletons. Now that's wonderful, but in .NET we learned that singletons make testing harder. We don't want to have a static thing. We want to have dependency injection allow us to inject the thing. And so in TypeScript, that's hard. We have those import statements at the top, or we have the require statements at the top. And it's, how do we get into that require to be able to adjust the parameters that we need? So what's interesting is in TypeScript, these interfaces only exist in design time. So if we were to, pass in this anemic object that only had two properties, then we could do fine in JavaScript. But then our TypeScript compiler would tell us, hey, you're missing some properties on this object that make that painful. The other part about interfaces that's interesting is that they only exist at design time. So in .NET, we can reflect on an object and we can pull out the properties. And in TypeScript, we can't do that. Given a type, we can't automatically mock that thing because at runtime, that type no longer exists. So in .NET, we have MOQ that allows us to just kind of take a type and auto-magically generate a thing. In TypeScript, we'll have to do that differently. So TypeScript requires that full interface implementation. So in my test where I had this big object, we would need to enumerate all of the properties. Or do we? So here's the scenarios that we need to start to combat. We need to be able to inject our dependencies. Now, this is probably more applicable to Angular, where we do have a full dependency injection system. But probably in our TypeScript code, we have a whole lot of imports. And we need to be able to mock those imports. We also need to be able to avoid irrelevant arguments into our parameters. So those are the things that we need to test. We need to be able to fake imports, and we need to be able to fake dependencies, or parameters. So let's take a look at some solutions that we might be able to leverage to make this happen. And we'll start from a naive approach and kind of walk through and then look at the code to see how these work. So here's our first attempt. I can just cast it to any. If I have an any, then of course I can feed that into my application. Yeah, no. If any is your go-to solution, then you're not coding in TypeScript, you're coding in JavaScript. You're lying to your TypeScript compiler. So any is interesting, but any is not a great solution here. Let's set that one aside. Next one, monkey patching. Now, in this case, I have a Lodash function, and I want to be able to override this Lodash function with my own implementation so I can have a more deterministic result. Now, that's cool. I just take that object, and I slap in my temporary function, and I'm able to do that. Now, this is great because I'm able to override the details inside this TypeScript library, but it doesn't come without its downsides. So, for example, if I import like this. Now, previously, I just said import underscore, and now I said import, and I pulled out that particular, I spread the object to be able to get that particular property. Now, in this case, if I override random, it's not the random inside Lodash, it's the random instance inside my test. So we need to go back to this one, and the hard part there is I'm importing the entire library even though I don't need it. Yeah. And I'm doing that so that I can get at that particular property inside this library to be able to override that functionality. And I need to do this before my library imports this content. Because if it maybe does some initialization content right at the top of its method, if I don't monkey patch it first, then I'm going to end up with the original instance, and then the monkey patch just happened downstream. Additionally, maybe other tests depend on the real implementation of this function. So I'll need to make sure that I put this code back after I'm done. So we took a look at monkey patching, and we see how it can be really beneficial. If we're just in JavaScript, this can be great. But we have some concerns. If we spread our imports, then that won't work. We need to make sure to put it back, and it's a little fragile. One of the things that bites me a lot down here at the end is it's really easy to forget to put it back if your test fails. So my test failed, I didn't put my mock back, the original one back, and now all of the other downstream tests failed too. So I went from 1 failing test to 100 failing tests, and it's like, no. So we'll see how to put things back in our tests today. TS AutoMock. TS AutoMock is a really cool package that allows us to generate mocks given a particular type. Now, as you grab these slides from robrich.org, here's another blue link, and you can learn more about TS AutoMock. We're going to dig into this library through the talk today. So here's an example instance of TS AutoMock. I've pulled in a particular type, and I want to say, go mock this type. Now, earlier I said the types aren't available at runtime, so we can't infer them. Yeah, I can't just take a of t and mock an of t, but I can, given a specific type, mock that. Now, this is cool. In the same way that in .NET we have MOQ that can automatically build us a thing, we can do this as well. Now, we can pass in the things that we care about. So in this case, I want to mock a request, and I want to give it a body that has particular values in it. Now, I don't care what else is in this object. I just care about this particular portion of it. Now, the cool part about TS Automock is it uses partial of t. If you've not used partial of t in TypeScript, it is amazing. Partial of t says, I don't need all of the properties of this object, but I do need that all of the ones that I specify need to exist. Now, the cool part is TS Automock can loop through the objects, the properties that I passed, and mock out the rest of them, which is great. You know, go take care of everything I don't care about and let me focus in on the particular ones that I want to. So TS Automock takes this partial of t and fills in the rest of the mock, and now I can use that to do stuff. Now, TS Automock does take a little bit to set up. Once I had this type of code in my thing, I had to then go create a config, and it took me a while before I could get this test to pass. But it's just magic to be able to pass in only those things that we care about and get this mock that takes care of everything else and satisfies TypeScript's interface. So we'll leverage TS Automock for passing in parameters into our methods. The other thing we can look at is TS mock imports. Now, TS mock imports is really good at faking out the imports that I need to be able to pass into my other things. Now, it is built on top of sign-on, and if you've ever used sign-on to be able to do similar mocking, either in TypeScript or in JavaScript, it does get a little bit hairy, but it's actually pretty cool. So I'll start by grabbing TS mock imports, and that'll give me this import mock. I'll grab sign-on just so I have the TypeScript declarations. I'll grab my dependency. Now, I have to grab it star as dependency. I have to grab all of the properties, not just the default. Or I can't spread it here because I'm going to replace a particular property on that object. Now, I'll grab my suite under test. Now, notice that I'm grabbing it even before I'm setting up my mock, which is pretty interesting. So here in my test, I'm going to create this mock. I'm going to say import mock.mock function. I'll pass in that object and the particular property that I want to override. I wish there was more design time hints on this because I'm passing in a string that just happens to exactly match the thing that I'm importing. And then I'll give it the return value, the thing that I want that method to do. And then I'll cast it into a sign-on stub just so that I can get that sign-on stub set in this spot. Now, when I call my function, which came out of this library, then I'm able to use my mock to be able to accomplish the task that I need to do. Now, to be a good citizen for my testing, I also need to put it back. So after each test, if I have this mock, I'm going to say mock.restore. And it looks like I need to go fix my code because here it's called store mock and here it's just called mock. But I'll go save that as a instance variable inside my test, and I'll put it back so that then future tests can use the regular library. And so that's TS mock imports, and it allows me to be able to grab my content and replace the instances there. Now, I do need to pull in my dependency before I pull in my suite under test, but that's kind of the only critical piece there. So TS mock imports. TS mock imports is great at being able to replace those import statements, and it does take a smidge to set up, but once I've got it set up, I can grab these sign-on fakes that allow me to be able to replace the imports for the suite that I want to test. Now, the cool part is that it's able to replace those pieces, but it is a little bit finicky. So I must specify the exact same file. If my code grabs /path/index, then my test must do that as well. It's actually matching, based on that string. And I have to cast the sign-on stub to the correct method. It's not going to double check that I didn't return a sign-on stub as a particular thing. So here we had to cast it as the sign-on stub of the particular input arguments and return type. And if we typoed that, TypeScript isn't going to help us very much, which is kind of a bummer. But TS mock imports is a great way to be able to get at that code. So let's dig into this application and take a look at it. The code for this is on GitHub right now. And so as we look at this, we can take a look at the application. Now we have this app that allows us to look through some stuff. We saw that app running previously. We have here in our source, we have app.view. Now app.view will render out that thing. It'll also render out the leaderboard. And the cool thing about this, let's open that up in VS Code, is this app is actually doing a lot of the work of the game loop. So here's that game loop, and it's going to do the things. Our particular components, for example, this leaderboard, is not going to reach out to any external services to get anything. It's just going to render the content straight away. Now that's really great. That means that our app is the one that does all of the coordination. Our components, now we don't need to mock our dependencies. That's great. App will actually reach out to update score. Update score came in from this, where is it? Update score came in from this data scores service. So let's come in here to data scores. And we can see how that just reaches out to my API to either get the current score or to be able to update the score. We can also clear the score. And so the rest of our content then lives on the server, which is really elegant. Here's our server method. So inside routes, we have an index route that just allows our API to render correctly once published. And then we have this score API. Now this is pretty cool. Here's that get method to go get the current score. And we're going to go get our app out of Redis. We did that here. We used, we grabbed this Redis client and we stuck it inside of app. Now I grant here inside my score API, I could have done something to initialize the Redis client here. That would make it a little bit more stateful. It would, or then I would have that one property that I would need to be able to destroy correctly to close down my app. So I chose instead to stick it here on my app instance. But that does create an interesting scenario here that will make this really fun to test. I need to go get this property out of this app, and then I need to pass that in to this method. Now my goal is to test this get method, not to test my Redis client or the get scores method. I want to be able to mock all of those out of the way. So another interesting thing is, before we get to that, let's do some client-side content. I want to test this leaderboard. Now, I'm just rendering information here, but I want to be able to mount this component so that I can validate behaviors on it. So I'll flip over to my tests. Here's my component tests on my leaderboard. And so I'm going to use test utils. Here's test utils for view, and I'm going to mount that component. So here's my component, my leaderboard component, and I'm just choosing to mount it. I can choose to pass in my props. And so in this case, I'm passing in a score list that happens to be empty. And I want to validate the rendering behavior on this test. So I'm just going to mount that component, grab the text out of the component, and I suspect it'll say leaderboard and clear scores. Now, as it renders this component, it does quite a lot of other things, but we can see that here's clear scores, and here's leaderboard. And if I'm stripping out all of the HTML tags, that's the only text that I'll be left with. And so thus, this test is able to validate that. I'm able to mount the component and be able to validate its rendering behavior because I mocked out the properties sent into it. Next, I'm going to pass some actual content to it. I'll mount this component. And now I want to go grab the text. Now the text is going to be all kinds of interesting things, but I want to validate that it says tie is 1. So here's tie and here's the score. This happens to be the only one in the list. And so I can mount that way. So that's a client-side test. Let's flip over instead to the server-side test and take a look at this method again. We've got this get method, and this get method is really interesting in that we'll be able to see some cool pieces around this get method. Now, I do need to mock out the get scores. That's an import. I'll need to mock out the request and the response because I don't care about a lot of things. But I do care that this app property has a get method that returns something that matches this interface. And so let's take a look at the tests we want to build inside this. So I want to be able to validate that if Redis returns null, it's going to use the default. So here in my application, I've got this thing that should return stuff. But if it doesn't return anything, let's go grab default. So default is another mock that I want to pull in, or another import that I want to pull in, and I want to mock those results. I don't care what it is. I just care that I have control over it. So here in this test, I'm going to say, here's my scores that I want my default to return. Here's my Redis scores. This is what Redis should return. And I've got this property, this scores property, that I'm going to go validate works correctly once I've finished running this test. So now I need to set up get scores, set up score default. Those are the two mocking the imports. And then I also want to mock request and response. Let's dig into that one first because I'm actually passing in a lambda that will allow me to get the body back out once I've passed it. Now that's interesting because down here at the bottom, it actually calls res.json. And if I'm mocking this response, I do need to capture the content there from that method. So let's dig into the mock request response one. Now I'm choosing to use create mock. Create mock came out of TS automock. So TS automock allows me to pass in a particular type. So here's Redis client. And when I pass in that type, I just want something that satisfies that type. So here's my mock, and it is of type Redis client. Excellent. I don't care what Redis client does. I just need to be able to pass it into place. Now I'm going to create a mock for a request. Now this is an express request. What's really elegant here is that there's a lot of things on request that I don't care about. But I do care about that it has this app property, and inside this app property, there's a get method. And when you call it, passing in, I don't know, anything, I'm going to return this Redis mock. Now I could validate that what you passed in was Redis client, but I'm going to pass in this Redis mock, which came from here. And so now I have a Redis mock that you can use inside this method. And now this I'm going to cast as a partial of request, just so that create automock knows that that's a part of a request, so it can fill out all the rest of the details. Now in this case, I didn't say as response. I just let create automock infer that. But now I have a response that just has a single method, a JSON method, that's going to take in a body that happens to have this type of thing. I'm going to call this on JSON body. Let me pass in some lambda so that you can keep track of it later. And then I'll return this as response in case I chain things. So I might call this .json.status code. And so I'll return that. So this allowed me to build up these mocks for request and response. Back here in my code, I have now a mock request and response. I'm going to pass those into my get method, which will come in here. Here's my get method. So here's my fake request and response. My fake request.app.get. So I've come back in here to my .app.get, which will get this fake Redis mock. Now the interesting thing is I don't care what that Redis client is. I just care that I pass it into here and everything will work. Now I need get scores to return nothing. So back here in my method, I've got Redis scores. Here's the thing that is undefined. And I want to set up get scores. So set up get scores is this method down here where I use import mock from TS mock imports. I'm going to mock a particular function on this object. So I pulled in score data here from my service. And I pulled it in star as score data so that I can be able to fake the particular property on the actual instance that will get used. And so I'm going to mock that import right here. I'm going to mock the getScores method, and I'm going to specifically return this object, the one that I passed in. And I'm going to cast it into this thing. I don't like that I have to cast it here. I wish TypeScript was able to infer that, but yeah, this just returns a sign-on stub of any, and I'm like, yeah, I guess the only way to solve that would be to be able to pass in things here, and that gets a little hairy. So I've returned this score mock, but I've also saved it in this variable. Now, as a good net citizen, we need to make sure that we're saving these things. So here's that score mock. And after each test, if this score mock was set, I'm going to restore it back to the original thing. So unattach my fake one, put back the real one. Similarly, I need to be able to mock out the default, because here, now that we've gotten this getScores to return undefined, we want to make sure that it calls this method to get its real default. So I've got this. Let's set it up to return default. Here's the default, and it just has some fake data here. Dig into this method, and we can see that that's going to set the default method on this particular import. And so what's interesting there is that score, nope, not that one. Score default, I'll actually come in this way. Here's my score, and my default score, you notice that I'm just grabbing the default import, so I'm not spreading it. So the cool part about this is that export default. Now, the cool part about export default is it just happens to be a thing on this object called default. So I can take advantage of that. I'm just going to call this default. I'm going to override default. Now I want to return the particular result. So, here's this particular result, and I'll save that off so I can restore it and return it if you need it. So I now have this test that will be able to validate if I pass in, nope, not that one. If I pass in a particular score and I have a particular Redis result, then I want the thing that response sent me to be the defaults. Excellent. Now that was kind of a long walk, and part of it was a little bit contrived because I intentionally didn't do optimizations here. Rather, I wanted to get this property and pass it in. But we can see that we were able to validate this test without a real Redis behind it. That was excellent. Now let's do a similar thing. When Redis has content, then we want to make sure that it returns that Redis content instead. So I'll do my setups, pass in the Redis scores, pass in my defaults. And now because Redis has results, notice that these scores are different. Once I run my thing, grab the scores, I want my scores to be these Redis scores. Now that was really cool. We were able to fake out our dependencies. We were able to fake out our parameters and only take control of those things that we needed to create a very deterministic result here. Let's do a similar thing on the post. So I want to be able to update my content. Now this is interesting because not only am I grabbing the Redis app out of the request, but I'm also grabbing the body out of the request, and it has a particular player. Let's validate that the player is a valid player. So I have this players array that I can take a look at right here, and here's my list of valid players. I also have a type that makes that happen, which is pretty cool. So let me go validate that it is a valid player, and if it's not, I'm going to return a 400. But if it is, then I'll update my scores, which will actually return the current scores and return that. So I've got a couple of things that I need to do. I need to mock out my app call. We saw how to do that previously. I need to set the body in an interesting way. I want to take one test through this code path to validate that if I pass in bad data, it works. And I want to take another pass through this that will actually update it and validate that I get the scores returned from this update score method. So here's my post, and we'll take a look at the happy path first. I call with a player of X. I expect the status to be 0, basically that I didn't call set status here. And I expect the JSON body to be Redis scores. So here's my Redis scores. I'm just going to create this mock that gets returned. I don't care what those values are, but I want to make sure that that's the one that comes back. So I'm going to mock this function, this score data update scores method. Now, previously, we just said, I want to create some things, but now we want to take a little bit more control over it. So I'm going to say, if you call that update scores method, I want it to do this process here. Now, I'll take in my Redis client. I really don't care about that, but I'm going to take in my player and the number that we want to increment by, and let me go validate that those are as we expect. That the player passed in is the player here, and that the number passed in is 1. You can't increment by more than 1. You can't win more than one game at a time. And so now that I've got my mock set up, let's make a fake request here. Now, in this case, we're going to pass in a little bit different configuration. Previously, we only said, let's go grab this JSON body, but we also need to be able to grab the status and be able to set the body here too. So this make mock request is a little bit different. I go create a fake Redis client. We saw that before. We go create the fake app method. We saw that before as well, but we're also setting up this body with whatever you happen to pass in here. Now, this is a partial of request. So now I have a request object. TS AutoMox is going to figure out the rest of the properties. Let's do a response. But now we're going to not only grab the JSON method, we'll also grab the status method and call our fake function, passing in the results back to whatever method you called me with. So now that we've got this mock set up, now this fake request and response, let's pass those into our method. So we'll go call post. Now we're passing in this right here. So we're passing in our fake request, which will go grab our app method. We saw that previously. It'll also go grab our body method. So that body method came in from our fake right here. Here's the body, and it grabs the particular player we passed in here. So back here inside of this, we expect that player to be to come in there. So once we've got this body, here's this JSON body that we got back out of it, and we'll validate that that JSON body is the Redis scores. Here's our Redis scores. It's just this fake thing, and that's the result of calling the Redis. So that was my happy path, and we're able to validate that. Then here's the unhappy path. If I pass in invalid players. Now in this case, I noticed that there was a couple of invalid players, so I could have written a test for each one, but that was starting to get really redundant. So I just have this array of invalid values, and I said for each of those, let's go build a new test inside this for each loop that will go test that invalid player. That's cool. Now I wanted to specifically error with this error, so let's validate that my JSON body is this error, and let's go validate that the status is the expected status of 400. So I'm mocking the request in the same way, I'm mocking the other content, and we can see that that works as expected. Rounding this out, we also have a delete test that does similar things. Now in this case, we care less about the particular details of those, because in the delete method, we don't need to grab anything from the request. We don't need to take different paths. We just need to know that the JSON method got called and that this reset scores method got called. So our delete one is actually really simple. Let's go fake out the reset scores method. Let's call request and response based on these fakes and validate that score mock was called. So now that that method was called, we will also put that score mock back at the end of each test, and we can validate that that works as expected too. So let's go run these tests. I'm going to start out on the server. So let's stop the server. Let's also stop the client. And I do have a package JSON here that will set up my test. Let's take a look at that real fast so that we know which method to call. This one just calls jest. Now the cool part here is jest will go look through, based on my jest config, it will go look through my tests directory. So all of these tests were in my test directory. I also have integration tests, which are pretty cool. They will just fire requests out at my API using get scores, using the request package. So let's do that. Now, because I have my integration tests, those are going to use actual Redis. These unit tests will not. npm run test. And let's see if we've got some passing tests. Now, server side, it's going to mock out both my imports and my dependencies and run those. We'll also get my integration test that will actually flex Redis. And it looks like that passed, which is excellent. That's always a good day. 8 total tests that it ran, and all of them passed. We can see some details about each of the tests. So our delete method, our post method, here's our get method, and both of those returned successfully. And we can also take a look at our client-side tests. So let's run npm run test. Before we do that, let's take a look at npm run test, because this is going to do some interesting stuff. Now, as I initialized my Vue app, it set up my test unit and test end-to-end, and I rigged up a test method, just so I could say npm run test, that runs my unit tests and it runs my end-to-end tests in headless mode. Now, the end-to-end tests are actually using Cypress, which is really cool. I'm passing in options legacy provider because I'm using node 17 to test Webpack 4. If I update my Vue CLI, then I can get rid of that. But that didn't work at 2 a.m. last night. So let's run our unit tests, which will go validate our components, also go validate our services. We can check particular wins that way. And if that works, then we'll run our end-to-end tests, which actually pick up our Selenium tests and validate our game loop works as expected. So npm run test. Let's run our unit tests. Here's where we're mounting components and validating the behavior there. We'll also run unit tests around do I win. Now we're kicking off our end-to-end tests. Now our end-to-end tests do assume that our server is running. So npm run serve, no, npm start. Should have done that first. Because our integration tests are going to flex from here down, it actually needs to have the server running too. So it looks like we're running our Electron app, our Electron browser rather, built into Cypress. In a different version of this talk, we actually dig deeper into the Cypress tests, and that's really cool. Looks like we have passing tests there, 6 passing Selenium tests. We also can take a look at our unit tests, and we have 19 passing unit tests, and we win. We were able to mock out the dependencies to focus in on the pieces that we really cared about. We mocked out our imports. We mocked out the other properties that we wanted to pass in. So if there were other details on a request, if we updated Express and they passed in things, we could just focus in on this portion of the request that we cared about. Now, in this case, I only wanted that app property to exist, so I had a get method so I could get a Redis thing on it. I only wanted to have a JSON method so I could collect the JSON body from that. All else being equal, I wish Sign-On did that for me. But that was really cool. We were able to mock out our dependencies and keep our TypeScript interface alive. So we focused in on 2 libraries, tsautomock and tsmockinports. tsmockinports uses partial of t. Partial of t is amazing on its own. If ever you want to grab the object but not the ID property, then you could use partial of t to say, I'm just going to have a patch of my object but not the entire object. So TS mock imports is really fun. Jest.function and sign-on stub. We actually didn't use jest.function, but we did use sign-on stub behind the scenes based on TS mock imports. TS mock imports to be able to fake out that method with the various details. So yeah, mocking in TypeScript. Use the right tool for the job. And ultimately, because we wanted to fake out those dependencies, because we wanted to focus in on just those things that we cared about, we're able to let the rest of our application go to make these tests run particularly fast. Now, the code for all of this is up on GitHub right now. You can head off to robrich.org, click on presentations, and grab the GitHub repository. And hopefully, if you run npm run test, then your test will pass too. This was a lot of fun. Thanks for letting me play. Any questions on mocking in TypeScript? Yes. Yeah, I would invite you to play with the GitHub repo. Thanks for coming.